Okay, this is the second video in the Applied Maths for Games Development series. This one is about fundamental arithmetic. And it may start off with something that's fairly obvious to you. It's some fairly obvious basic operators in arithmetic. And the first one, you can't get much more simple than negation. So the negation operator is the simplest thing you can do to a number because all you do is negate it. Stick a minus sign in front, it becomes a negative. So the number 5, if you stick a minus sign in front, it becomes negative 5. And if you stick a minus sign in front of a minus 3, then it becomes negative minus 3, which is the same as plus 3. Negation only needs you to have one input number, so it's called a unary operator, as opposed to a binary operator like 1 plus 1, because it has two numbers as input. Next up, we've got incrementation and decrementation, two related operators. So incrementation is where you start with one number and go from there up to the next highest number. This is the basis of most arithmetic, but mathematicians tend to call it the successor function, if they even bother talking about it at all. And that's there. The successor function, s of n, is defined by n plus 1. So if you put any number as an input, you'll get that number plus 1 as an output. So take 5 and put it into the successor function, you get 5 plus 1, which is 6. Programmers, though, call it incrementation, and it's done using usually that command there, n++ or x++ or C++. Ha, aren't programmers hilarious? There is, of course, decrement too, which is the same thing but in reverse. Okay, moving on to some more useful operators. There's addition. So the plus symbol combines two different numbers, so that's what we call a binary operator. And technically, it is what we call a hyperoperation. And a hyperoperation is where one operation repeats some other operation. So if you keep on doing the successor function, keep on adding 1, then you'll get any kind of addition you like. If you want to add on 5, for instance, you repeat the increment 5 times. So x plus 5 means take the number take whatever x is and get the successor to it 5 times. You don't usually consider it that way, although a lot of children do learn it that way at school when they're first learning to add numbers. So some properties of the addition operator. It's commutative, which means the numbers on either side of the plus sign can move around. They can commute, if you like, hence the name commutative. 3 plus 7, swap them around, 7 plus 3 gives you the same answer. Addition is also associative, so if you have something being added inside brackets and you're adding something else on outside of the brackets, you can associate that number, the numbers in that expression, in two different ways. You can put brackets around the second set of numbers or the first set of numbers. It doesn't matter, but you get the same answer. Addition is a binary operation, as we said. So the two numbers that you're adding together, they're technically referred to as addends, probably not a name you've often heard them called, but the answer you get is called a sum. Then you have subtraction, of course, the opposite. The reverse of addition is basically repeated decrements. It's not commutative, but it is anti-commutative. And what that means is if you take the two terms in the expression and swap them around, you can do that as long as you put them inside brackets with a minus sign in front. So, for example, 6 minus 4, if you try and make that 4 minus 6, it's not equal unless you put a minus sign in front of that whole thing. So 6 minus 4 is the same as negative brackets 4 minus 6. It's not associative, so if you have three numbers, one being subtracted from the next, the order you do the subtraction in does matter. For example, on the left there, 9 minus brackets 4 minus 2. Well, 4 minus 2 is 2, so that's asking you 9 minus 2, which is 7. It's not the same thing if you do it the other way around. If you do the 9 minus 4 first, like on the right-hand side example, 9 minus 4 is 5, 5 minus 2 is 3. You get a different answer, so it's not associative. It's still a binary operator, so again, they've got fancy names, which you don't often use. The larger number, I should say the numbers you're subtracting from is called the minuend, and the number you're subtracting from it is the subtrahend. Don't normally hear those names, but you do often hear the answer being called the difference between two numbers. Moving on, you've got multiplication. It's another hyperoperation. Basically, if you multiply by something, you're more or less asking them to repeat the addition. So multiplication is shown by the cross symbol. We sometimes replace that with a dot so we don't confuse it with the letter X. Or in a computer programming environment, you would use an asterisk usually, which is the star symbol. Multiplication is commutative. 3 times 5 is the same as 5 times 3. It is associative. 2 times brackets 4 times 5 is the same as brackets 2 times 4 times 5. The order doesn't matter as long as it's all multiplications that are being done. It is also, here's a new property, it's distributive with respect to add and subtract. So if you have 2 times brackets 3 plus 4, that's the same as 2 times 3 plus 2 times 4. You're distributing that 2 between all the terms inside the brackets. And that would apply if that was a minus sign as well. It's also binary. So if you take the two inputs, we can call them the multiplier and the multiplicand. But because it doesn't matter what order they're in, we often just call them factors. Two factors multiplied together gives you the product. Next up, we've got division. Division is the inverse operation of multiplication. And inverse means if you have any two operations, then one applied followed by the other will reverse it. So for example, if you do an addition, add 5, and then you subtract 5, that's the inverse. So you end up with the same number you started with. So that's basically what inverses mean. We'll see a lot of them going forward though. So division uses that symbol there. It's called the obulus, but it's very hard to type that on a computer. So we use a slash symbol in almost all programming languages for division. Division is not commutative. 10 divided by 5 is not the same as 5 divided by 10. It's not associative. So 20 divided by brackets 10 minus 5, well, that would give you 20 divided by 2, which is 10. That's not the same as brackets 20 divided by 10 divided by 5. So in that case, 20 divided by 10, that would be 2. 2 divided by 5 is 0.4. Different answer, not associative. But it is distributive, just like the multiplication operation. So 24 minus 16 in brackets, then divided by 4. You can distribute the divide by 4 between the things inside the brackets. So 24 divided by 4 minus 16 divided by 4. But the order does matter. So I'm sure you've all seen examples of this kind of thing on social media. Only for geniuses, this kind of thing that tries to make you feel smart or stupid. So that's based on the idea of operator priority. So in math, there is an agreed upon order to do things in, and it is only an agreement. There's no reason why we couldn't do things in a different order. Well, perhaps the reason is that it might be a bit harder to work things out sometimes, but it's just a convention. And it's called BODMAS or PEMDAS or some other names as well in different countries. BODMAS tends to be more of the UK version and PEMDAS the American one. They stand for brackets orders, not or, by the way. Don't say brackets or division. That implies that it doesn't matter whether you do the brackets first or the division first, and that's not true. Brackets do always come first. Also, if you skip the O part, the orders, then that's missing out exponents or orders or powers, whatever you want to call them. So anyway, brackets, orders, division and multiplication. Notice how those are combined. So you do division and multiplication as the same step, and then add and subtract, again, the same step. In the American style, we've got the same operations, just different names. Parentheses is just a more technically accurate name for brackets. Exponents is just a less old-fashioned name for orders. And division and multiplication is fine to swap them around because they're the same step. So it's the same priority we're describing there. So if there's anything in brackets, do them first, then any exponents, for example, squares, square roots, etc. Then do multiplication and division, but you need to do them from left to right. That's the convention. Then you do addition and subtraction at the same time, again from left to right. So in this example, 3 minus 3 times 6 plus 2. Well, there's no brackets. We could put brackets in, as I have on the example on the right, just to indicate more strongly that we do the 3 times the 6 first. We don't need brackets in there because BODMAS tells us that we do the multiplication before add and subtract. So I've only put those brackets in to clarify. But yeah, we do the 3 times 6 first. We get 18. So it's left with 3 minus 18 plus 2. Now we do add and subtract in order from left to right. So 3 minus 18 first, that gives us negative 15. Then you add on the 2, that gives us minus 13. So what is an exponent? An exponent is just another hyperoperation. In this case, we repeat multiplication. Exponents are also called orders, indices, or powers. It's indicated by a superscript after a number or variable. So, for example, 17 to the power 4, that's how we'd pronounce that. 17 to the power 4 tells you essentially that we do a multiplication with 4 17s in it. So 17 times 17 times 17 times 17. And in computing, we sometimes represent that with a caret symbol. That little thing there is occasionally called a hat, but its proper name is a caret, not the kind you eat. But there we go, 17 to the power 4, 17 times 17 times 17 times 17. Unfortunately, in C# there is no such operator, so we have to put in a function. But that is there in some languages. Exponents are a binary operation. You've got two numbers, the base and the exponent. And as I've said there, it's something described that way, so 17 to the power 4. If you raise something to the power 2, that's a special one. It's called squaring, because if you have a square with a certain length of a side, you can get the area of the square by multiplying it by itself. For the same idea, by the way, that's why power 3 is called cubed. You can get the volume of a cube by taking the width or the height or the depth and multiplying it by itself twice. So x times x times x gives you the volume of a cube with sides of length x. Any other exponent though, it's just called the nth power, so 4th power, 5th power, 6th power, etc. That leads us on to roots, because roots are actually just the inverse of raising something to the power. In fact, technically, a root is a power. So a root is a number that must be raised to a certain power in order to find the answer. Makes it the inverse of the exponent. And it's indicated by that sort of radix symbol, that vaguely R-looking shaped symbol above the 16. It's called a radix or radical symbol. And it tells you which number you want to find the square root of. So square root of 16 is 4, because 4 times 4 is 16. Square root of 9 would be 3, because 3 times 3 is 9, and so on. If you need to find a cube root or an nth root, you put in a degree, and that's just a number above and to the left of the radix symbol. So the cube root of 125 is 5, because 5 times 5 times 5 cube equals 125. Next operation we've got is factorials. A factorial is an integer operation where you multiply each number from 1 up to and including the number given. So only whole numbers, and let's say you get factorial 5 exclamation mark, that's how it's indicated. So you multiply 1 by 2 by 3 by 4 by 5, or as it's shown there, 5 by 4 by 3 by 2 by 1. And if you're smart, you may have noticed you can skip that last one, because multiply by 1 just gives you the same answer. But that's it in full. Factorials are really useful in statistics, and they can become unreasonably large answers very easily. Factorials of something like 30 can be pretty huge, but they are still used, and you have to be very careful with them, because they can overflow your data types quite easily. Oh, and there is a special rule for 0, as there often is in these kind of things. So the factorial of 0, we've declared that that's as 1, in case there was any question over it. Okay, now let's look at percentages. Now percent, I'm not sure if that's Latin or French or what, but it means for every 100. So a percentage is a value out of 100. If you've got 100% of something, that's a whole thing. So 100% is actually equal to 1. Some people get confused by that idea, but think of it this way. If you go into a shop and everything's 50% off, we instinctively know by now that means half price. So if 50% is half, then 100% is both halves, the whole thing. Maybe that will help, right? So 50% is a half, 100% is a whole. So if you want to convert a percentage into a fraction, you really just need to think of a percentage as a fraction where the denominator is 100. So 25% is really just the same as 25 over 100. But sometimes these fractions can be simplified or reduced to use smaller numbers. For example, 25 over 100 is the same as 1 over 4, or a quarter. If you think you can do this, just divide both the numerator and denominator, which is the numbers above and below the line on the fraction, by the largest common divisor. And the largest common divisor is the biggest number they can both be divided by. In this case, it was 25. I seem to have duplicated that page. Apologies. Oh, wait, sorry. No, it's not quite. If you want to convert a percentage into decimal, a percentage is really just a fraction. And a fraction can be made into a decimal. So percentages are particularly easy to do this with because the denominator is a multiple of the base. So for example, if you take the number 25%, so 25 is the number of percentages, whatever you want to call them. So 25, if you divide that by 100, you get 0.25. If that's hard for you to imagine, then think of 100%. If you move that 2 decimal places to the right, you would get 1.00. So 100% is one whole thing. What if you have to convert a fraction to a decimal? Well, this one's really easy. You just divide the numerator by the denominator. At least it sounds easy, but there is a catch. Sometimes divisions, you can't end it. You keep on going. So for example, 1/3, it gives you 0.33333333333, etc. So this one doesn't have what's called a terminating digit because that 3 goes on forever. So a repeating sequence can be indicated though by putting a bar over whichever digit or digits repeat, sometimes a dot instead. So that's how you would represent 1 divided by 3 as a decimal. If you want to convert fractions into percentages, you can just simply divide the numerator by the denominator and then multiply by 100. But there is a fancier way. You can find the largest number that you can multiply the denominator. Sorry, you can find the number that you multiply the denominator by to get 100, and then multiply both of those numbers on either side of the fraction by that number. So you will get 100 on one side. Once you've got that, you then do the division. If that seems long-winded, then just stick with the calculator route. It gives you the exact same thing. If you need to convert decimals into percentages, that I keep saying easy, but this one is actually easy. Multiply by 100. That's all you do. Turn a decimal into a fraction though. I did leave this to last because it's a bit harder. So if you've got a non-repeating decimal, like 0.5 or 0.25, you can turn it into a fraction by put the decimal number as the numerator and put the denominator as 1. Anything divided by 1 is itself, so you can always put something into a fraction with 1 at the bottom. Then what you do is you keep multiplying both the numerator and denominator by 10. So if you multiply both sides of a fraction by 10, you're allowed to do that because you'll get the same value. But the numerator then is going up. And if you keep on doing that, eventually, because it is a terminating decimal, eventually you're guaranteed that you will get an integer number on top. Once you get there, you reduce the fraction. But if it's a repeating fraction, unfortunately, there's another thing you've got to do. So expand, oh, you know what, I'm going to read this, but I doubt you'll take it in the first time. You're best to see an example. So expand the number by multiplying by 10 repeatedly until you get the repeating decimal, the digits that repeat, just to the right of the decimal place. And then you expand it one more time so that you get a different number, but with the same digits repeating on the right-hand side of the decimal place. So you got two numbers then that both have the same repeating digits on the right-hand side, so you can subtract one from the other and get a whole number with no repeating digits because they cancel out. Once you've got that, you divide by the coefficient and reduce the fraction. Did you understand all that? Let me show you an example. 0.086 repeating. I doubt you'll be able to tell me what the fraction that is off the top of your head. So let's multiply it by 100, for instance. That gives us 8.6 repeating. Multiply it by 1,000, you get 86.6 repeating. So they both have a 0.6 repeating on the right-hand side. So if you take 1,000 of them and subtract that 100 of them that we worked out just a moment before, that's 86.6 repeating minus 8.6 repeating. So the 0.6 repeatings cancel out. You're left with 86 minus 8, which is 78. So 900 lots of x is 78. So therefore, x is equal to 78 over 900. divide both sides by 900. So the fraction is 78 over 900, but you can reduce that by dividing by, what is it, 1, 2, by 6. So that gives us a simplified fraction of 13/150ths. Not an easy procedure by any means, but that's how you convert a non-terminating decimal into a fraction. And that's all for now.